So let's do that. What we have is a curve, and we're going to break the curve up from A to B with these lines. I'll say there's a line here. It's called delta L. And we're going to add all the delta L's, huh? We're going to add all the delta L's. So we're going to sum the delta L. Of course, it'll take a minute. What's the integral of delta L? What's the integral of dx?
1.
What's the integral of dp?
1. P.
What's the integral of delta L?
L.
L. What do we want? You know your antiderivatives. Derivative of p is 1. Derivative of x is 1. So delta L is this squared plus this squared. What is this? Delta x. What is this? Delta y. So you see the delta L squared. Delta L squared is delta x squared plus delta y squared. That is the Pythagorean theorem. Delta L squared is equal to delta x squared plus delta y squared. This is nothing but the Pythagorean theorem because I'm using straight lines. Everyone with me? Now what I'm going to do is I'm going to take a factor of delta x squared out. If I take a factor of delta x squared out, what does this become?
Y squared.
1 plus
Delta Y squared.
delta y squared over delta x squared. You don't know how to factor, right? Check it, delta x squared, delta y squared. Yes? We good with our algebra? So delta L squared is equal to 1 plus delta y over delta x squared times delta x squared. Well, I don't want delta L squared. What do I want?
Delta.
Delta L. So what do I do?
Take the square root.
Take the square root of both sides. Delta L is equal to the square root of 1 plus delta y over delta x squared times, what's the square root of delta x squared? Delta x.
Oh, that's why you factor delta.
Yes. I need to know some algebra. Now I will add these all up. And now let delta x go to 0. This is going to become an integral. What's this going to become? The integral of what? The square root of 1 plus the derivative squared. And this? Dx. What is this? No.
No.
Of course, I will have to be integration right away.
A. Or
Now you'll put your pen down. This says, if you want to find the exact length under the function y, or f of x, y is f of x. If you want to find the exact length of the curve, y equals f of x, between a and b, if you want to find the exact length of the curve, y equals f of x, between a and b, the exact length, you're going to have to take the derivative of your function, square it, then add 1 to it, take the square root of that, and find its antiderivative. That is what it says. Okay, not so nice, but let's still do it. That is to say, if you want to find the exact length of the curve y equals f of x, take the derivative of y, square it, add 1, take the square root, find the antiderivative of whatever function you get. This is going to be a strange function, huh? Involving x's. Integrate that function, in other words, find its antiderivative, and evaluate it at b, and evaluate it at a, and you will have your answer. And if you do not know how to find the antiderivative, what will you do? You will approximate this with a Simpson trapezoid. Let's do an example.
Oh, I think I figured it out. What, you're continuing about another function? I think I got it. I mean, I'm looking, consider for calculus 3. I looked at, like,
Yes.
we got the answer 20.66. And just like for comparison, like I did it across the y-axis.
So here's a curve.
9.14.
Y equals 4 cosine x. And we are looking at this curve between x equals 0 and x equals pi. We don't know what the curve looks like, cosine x. The graph curve is not so important. Cosine x looks something like this. I want to know what is the exact length of that curve. So this says you're going to have to set up an integral from where to where? 0 to pi, the square root of 1 plus the derivative of y squared. Take the square root and integrate it. So now I need the derivative of this function. What is my derivative? -4 sine x. I'm going to need to square it. And put that here. One plus what?
16 sounds
Ms. Heather, do you know the antiderivative of this? No, you probably don't. That's a hard one. You'll have to wait about 2 weeks. But you could certainly do it in trapezoidal rule or something like that. You take this function, not this function here. Okay, you want to do a trapezoidal rule of this thing, or a midpoint rule of this thing. Oh, you try it. Yeah. First set up the integral, then we'll do it by a midpoint rule. Yeah.
Wow, calculated. I just plugged it in to see, and now it just spits back out an integral. There's no real way.
Well, we will see in a couple of weeks how to do some trig integrals.
Oh,
Yeah. But as you said, as I told you, I'm planning ahead of it. I should say a prayer. That's what you should do. Otherwise, you got your potential.
right.
Because this is a definite integral. It's going to be a number. You can just use a Simpsons rule or something. You set up the integral?
So.
Square, huh? What is do you want? You have to square it? Not square it?
There we go.
Yeah, she's square it.
Did you get next word?